Hello everybody. I wanted to show a do-it-yourself design of a new point motor. I've developed a point motor based upon a geared DC motor, which you can buy for €2.50 from AliExpress. This thing is solely made out of PCB components, so you don't have to 3D print something or do something difficult. It is particularly designed to be relatively easy to manufacture. The base, it mainly exists out of three printed circuit boards. We have the base plate, the bracket. The mounting bracket also has an extra part that you can stuck through the main board, and then you can solder 8 of these solder joints for a solid connection. And there is this small wing shaped thing on which rotates. This part rotates. I use micro switches for the limits. This is an M2 sleeve, and you can mount a bolt and a nut, and the bolt is supposed to push in the switches when it rotates. I have two pair of switches because these two switches, they are designed for frog polarization, and the other two are for the actual motor limits. Now you can see there is some electronics involved, but not particularly much, and 80% of it is optional, and I will explain how it exactly works. The schematic. This is the core schematic of the motor. You have the main two leads, the motors itself, two diodes, and the switches. This is also how a tortoise drive works. The general idea is that you polarize these two wires, so you make one positive, one negative. If this one is positive, the current flows through the motor, through one of the diodes, through one of the switches, back to the power source. When the switch is pressed in, the current can no longer flow in this direction. At that point you can reverse polarity, and then the current can flow through the wire, but via the other switch, via the other diode, back into the motor, until this switch is made. Now there is this part of electronics, because you cannot connect this to a conventional DCC decoder. You can connect this via a switch, so if you don't want any of those decoder stuff, you don't have to. If you would like to use a decoder, you can use this circuitry. What I just explained about polarizing these two wires, this circuit does precisely that. If you don't want to use this circuit, you can simply solder these two solder pads. They can be found underneath the diodes, and then you don't have to use it. So it is completely optional, but if you want to use with DCC solenoid decoders, you can. And there is also, of course, the small part about frog juicing. The reason why I made this, because it is a simple design. With the cheap motor of $2.50 and a few micro switches, you can probably assemble this thing for, I don't know, let's say £5. I don't know. I will publicly host this design. Well, I'm already doing that, but I want to make a prototype first. I will probably have to redesign this wing 1 or 2 times. One of the things I want to change is, instead of these sleeves, I want to use fixed holes, so you can select the amount of millimeters more accurately, or more easier. I don't know how well this will work. They have to push both switches, but I don't expect that will be a problem. And I think that is a really neat design. The PCB itself, it is also not incredibly big. It is only 3 centimeters wide, and well, it's become slightly longer because of those transistors. And it is now 46.5 millimeters in length. Yeah, it is somewhat bigger than an MP1, that is true. Yeah, but yeah, it's still not incredibly big. I think that this cheap design may be of value for some people. Yeah, I think you can manufacture one of them, I think, under the 10 minutes. Especially if you don't want the extra circuitry. Yeah, please let me know what you think about it. And if you have any ideas to even improve it, just let me know. I myself was thinking to make a separate DCC decoder so you can power this thing with a single decoder. With a simple Atiny chip or something, you can make incredibly cheap DCC decoders. But thankfully this one worked without software. So again, please let me know what you think, and a good evening to you.